Okay, we can get started now. Dennis, I'll turn it over to you.
Hi, this is Dennis Sanger. I'm a software developer with Avaya. I've been working on products such as Communication Manager and Session Manager for the past 36 years. You know, a big part of my job is not just developing products that help you solve your problems, but also communicating to you how you can use these products to solve your problems. So that's what this talk is about today. I've done a few of these talks, and one I did last year was about adaptation in general. Session Manager has several different flavors of adaptation. I didn't really get to talk about regular expression adaptation very much, and it's a very powerful feature, and I'd like to show you some examples of how you can use it to solve real-world problems. So let's dive in. The agenda for today. So given that this is supposed to be a very technical deep dive, I'm not going to spend a lot of time on background. We'll do a very quick review of what regular expression adaptation is, a very quick overview of regular expressions, and then we'll just dive into 5 different examples of actual problems that customers have brought to us and that we've been able to solve with regular expression adaptation. So the quick review. What is adaptation? At a very high level, it's a feature that lets you modify SIP messages as they enter Session Manager. That's what we call ingress adaptation. Or as they leave Session Manager, that would be egress adaptation. And traditionally, what customers have wanted to modify is digit strings. But when you're dealing with SIP, there are all sorts of different SIP headers that you might want to modify to create different effects. So we've expanded beyond just digit adaptation, and that's what regular expression adaptation is all about. You can use regular expressions to manipulate pretty much any part of a SIP message. There's a handful of pieces which are not allowed to change, but beyond those, anything's fair game. There's an additional feature called device mapping. Well, first of all, adaptation, in the traditional definition is modifying SIP messages as they come and go between Session Manager and other SIP entities, not endpoints necessarily. Device mapping expands this capability to SIP endpoints, whether they're Avaya endpoints or other vendor endpoints. And you'll see an example of that as well. A very quick review of regular expressions. A regular expression is just a sequence of characters that we're going to use to match a string. There's a question about hearing music in the background. I really don't know why that would be. Anyhow, onward. So there are 2 kinds of characters you're going to see in a regular expression. There are regular characters, which are just upper, lowercase letters, numbers, punctuation. And then there are meta characters. The main 2 categories of meta characters are wildcards and quantifiers. And I mean, this may sound intimidating, but really 99% of the regular expressions you're going to look at will have regular characters and the big 4 meta characters. That's dot, question mark, plus, and star. The dot is a wildcard that matches any character, and the quantifiers let you specify how many of the preceding character you want to match. So a question mark matches 0 or 1. A plus will match 1 or more. A star will match 0 or more. So with just these 4 meta characters, you can already create all sorts of interesting effects. If you wanted to use one of these 4 meta characters literally, so you literally want to match a question mark, for example, just put a backslash in front of it. A few quick examples of regular expressions here. So the expression A3 semicolon C doesn't have any meta characters in it. It's going to match exactly A3 semicolon C. The regular expression A dot star F matches an infinite number of strings. For example, AF, A5F, A2B pound F, and just any other combination you can think of. So it starts with an A, ends with an F, and in between those 2, you can have anything. SIP S question mark, you're going to see that one a lot today. That will match SIP followed by 0 or 1 of the character S. So what that comes down to is it matches SIP or SIP S. We'll be using that one a few times. And finally, \a\.b. Recall that the backslash escapes the meta characters so that they're used literally. This will match only +a.b. So the meta characters aren't meta characters in this context because they have a backslash in front of them. And there is lots more information available on the internet about regular expressions. The main thing you need to know about the regular expressions is that when you're using Session Manager's regular expression adaptation, you're going to be using the Java flavor of regular expressions. Other languages like Perl and Python have slightly different spins on regular expressions. At a high level, they're all the same, but when you get into the nitty-gritty details, there are some slight differences. So just be aware that what we're talking about here is the Java flavor of regular expressions. Okay, enough review. Well, not quite enough review. Let's talk about what regular expression adaptation is. What exactly is it you're going to set up on your system manager? So each regular expression adaptation has a list of ingress rules and a list of egress rules. And it's okay for that list to have 0 rules in it. You could have just ingress rules, no egress rules, or vice versa. That's fine. It's 1 or more rules. Typically, you're not going to have more than, say, 5 rules in a particular adaptation, but you could go beyond that if you wanted to. Each rule has a condition, a regular expression-based condition that has to match in order for the rule to be executed. If you fail the condition, you don't execute the rule. You don't have to have a condition. You can execute the rule unconditionally, but if you want the rule to apply only in certain very specific conditions, then add a regular expression condition. We'll see an example of that later. Each rule can have variables that you set based on regular expression matching on the SIP message. You don't have to use variables. They're just there for you to use if you want to pull something out of the SIP message and then insert it into a different part of the SIP message. And then each rule has a list of actions that are going to be performed. This is the meat of the adaptation right here. 1 or more actions. If the condition passed, you're going to perform these actions. And the actions fall into 3 categories. You can add, modify, or delete part of the message. And if you're modifying the message, or if you're adding a header, you can use the variables that you set previously. There's a lot more information about all this in the Session Manager Release 8.0.1 white paper. It's available at avaya.com. I've pasted this link into the chat, so you don't have to scribble it down in a hurry right now. Lots of information there, examples. I encourage you to check that out if you want to use regular expression adaptations. So let's dive right into some examples. And these are all examples that customers brought to us. These aren't things we just made up in the lab. These are real customer problems. The first example is a fairly simple one. We'll start easy and we'll get more complicated as we go. So this one's about changing alternate routing behavior. The customer request was, I send an invite to a service provider, I get back a 606 not acceptable failure response, and the invite doesn't alternate route. I've set up alternate routing, but this call isn't alternate routing. And that's because there's a specific subset of all the responses that will cause alternate routing. Generally speaking, anything between 400 and 504 will cause alternate routing. There are a couple of exceptions, like, for example, 404. If you get back a 404 response, that more or less means that there's something wrong with the digit string in your invite, and you don't really want to alternate route because it's not going to work any better with a different service provider. Response codes outside that range will not alternate route. But, you know, different service providers do different things. So maybe you have a service provider who sends you a 606 for whatever reason, and you want to go to a second service provider who will maybe be able to route that call. I see another question. Is there a limit to the number of rules per adaptation? There is not a set limit. As with a lot of things on System Manager and Session Manager, there's not a set limit, but there is a limit that we've tested to, and there's also a limit to memory. so you can't keep an infinite number of rules in memory. You will run out of memory at some time, but practically speaking, I don't think you're ever going to smack into a limit. I find that if you have more than, say, 5 rules in an adaptation, it just gets unwieldy and hard to really manage. But you can go beyond 5 if you really want to. Okay, so the alternate routing problem we've got here. The solution, you can use regular expression adaptation to change the response code from 606, which doesn't alternate route, to 503, which does alternate route. So let's do a quick review of alternate routing. You set up alternate routing on dial patterns in System Manager. My example here, I've got a pattern that's 5777 with a minimum of 5 digits and a maximum of 5 digits. If I match that digit string, I've got 2 routing policies I can route that to. And you'll notice that they have different ranks. One of them has rank 100, the other is rank 999. If the ranks are different, then we're going to try the numerically lower ranked routing policy first. If it succeeds, we're done. If it fails, then we're going to go to the second one. If you gave your 2 routing policies equivalent ranks, then Session Manager would randomly choose between the 2, creating a load balancing effect. You'd get a 50-50 load balancing, basically. But in this case, we want to go to the first routing policy, and if that fails, we go to the second routing policy. What that looks like is this. You've got an invite coming into Session Manager, and Session Manager does the routing calculation, sends it to Service Provider 1. Service Provider 1 returns a 503 response. 503 is one of those responses that causes alternate routing. Session Manager looks at the second routing policy and routes the invite to Service Provider 2. It's an example of alternate routing. Let's see, we've got another question here. Are the rules scanned exhaustively, or is it scanned until you find a rule and stop? The rules are applied one after another. So the conditions are checked, and any rule that has a condition that passes will get executed. So you'll just march down the list of rules. Okay, so here we have the example of alternate routing. If we get a 606 response, there's no alternate routing. So what happens here is the 606 comes back and it gets proxied back to the caller. So the call will fail. Presumably, whatever endpoint you're calling from, you'll hear something like fast busy. So call fails. Now, if you want the call to go to the second service provider instead, we're going to change that 606 to a 503 to make alternate routing happen. Another question. Yeah, the inevitable question about why you wouldn't do this at the SBC. There are a couple of reasons you wouldn't do this at the SBC. It's really up to you to decide whether you like to do this kind of thing on your SBC or whether you like to do it on the Session Manager. But I can give you a couple of reasons why you might want to do it on the Session Manager. One is that you can use these adaptations to make changes to SIP messages inside your enterprise. So when you're not crossing an SBC. From CM to voicemail, for example, you're going through your Session Manager, you come from CM, go through the Session Manager, go to voicemail. You've got maybe a third-party voicemail that doesn't play nice with the Communication Manager. You need to tweak some headers. You can do it in Session Manager. You don't have to put a session border controller between your Communication Manager and your voicemail. The second reason is we got some feedback from a very large customer that was waving a check in our faces and saying, you know, we like the stuff we can do on the SBC, but man, you have to learn this scripting language and it's just really hard to get it right. Can you simplify this somehow? And I think what we've come up with here, it's all GUI based. I think it's a little simpler to use, well, maybe even a lot simpler to use than the scripting language you're going to find on an SBC. So if you don't want to become an expert in the SBC scripting language for modifying SIP messages, you can dip your toe in the water, so to speak, by using Session Manager's adaptation, and it's all fairly easy to use, fairly intuitive, GUI-based, no scripting language to learn. So here's what this is going to look like on System Manager. You go to the regular expression, you give it a name, and then you start adding rules. For this particular application, all we need is one rule to change the 606 alternate routing. When you go into the rule has to have a name. I happen to give it the same name as the adaptation itself. You can optionally add a condition. We don't need a condition here. This is an incoming rule, so incoming from Session Manager's perspective. We don't need a variable for this particular rule, and there's only going to be one action. It's a pretty simple action. The operation is modify. We're going to modify the status code. So the source type is response line. There are four source types. There's request line, response line, header, and attachment. In this case, we're going to specify the source type response line, and within the response line source type, you can specify status code or reason code. In this case, we want to modify the status code. The reason phrase doesn't particularly matter. The operation is modify. We're going to match 606. So only if the response, if the status code is 606, are we going to take action here. If we see a 606, we're going to replace it with a 503. That's all there is to this rule. So a very simple example of a regular expression adaptation. And once we apply this adaptation, this is what happens. The invite comes in, goes to the service provider, a 606 comes back. Session Manager is going to change that 606 to a 503. A 503 causes alternate routing, so the invite's going to go to service provider 2. Okay, that is the simplest example you're going to see today. It's going to get more complicated pretty quickly. Let's move to our second example. Any further questions on this one? Doesn't look like. We'll move on to the second example. Changing outgoing displays. This is a SIP header called ALTERNATE-CLI that gets populated by Communication Manager. So if you have an outbound call center, CM is going to populate the ALTERNATE-CLI header with a preferred display name, a display name that you would like your customer at home to see when they get this call. But the p-asserted identity header does not contain that display name. It contains the actual display name of whoever's making the call on CM. So whatever CM endpoint is generating this call. That's not the display you want the customer to see. So the solution here is to use the adaptation to replace the p-asserted identity header. That's the header that's used to generate a caller ID for the person at home. You're going to replace the p-asserted identity header with the content of the ALTERNATE-CLI header. It's still not a very complicated example, but it does show off a few more of the capabilities here. So what you're going to see in the invite from CM to SM, you've got a PAI header here with the extension of whoever's placing this call. In this example, it's 5666. In quotes, you've got the display name, so the name of the person placing the call, if you've got it administered that way. And then you've got the SIP URI of the caller. In the ALTERNATE-CLI header, this is what you want displayed, and the caller ID for the person you're calling. In this example, it's wealth management. What you want in the invite going from Session Manager to the service provider is a PAI header that contains the display name, wealth management, in quotes, and then the SIP URI, SIP:"wealthmanagement@avaya.com. And you'll notice that the space in wealth management has been escaped into a %20 that's mandated by SIP. RFC 3261, you can't have a space in a request URI or in any URI. So that has to be escaped to a %20. So let's see how this works. So here's the rule I'm going to be using. I give it the name ALTERNATE-CLI. There's no condition on this one. It's an incoming rule, and we're going to use a variable. So we let's dig deeper. We've got one variable we're going to set, and then there are two actions we're going to take. Let's dig deeper into those on the next slide. So first, we're going to read the content of the ALTERNATE-CLI header into a named variable called alternate-CLI. The source type for this is going to be header, and the specific header we're pulling this out of is the alternate-CLI header. That's the source. You need to specify an instance. There are some SIP headers that you can have multiple instances of, for example, route or via or record route. In those cases, you need to specify which instance you want to operate on, whether it's the first, the second, the third, or whatever. Alternate-CLI, you're only going to have one, but you still need to specify the instance. You can specify the instance as an integer, so 1, 2, 3, and so on. You can use negative integers to count from the bottom, so -1 would be the last header of that type. And there are a couple of helpful aliases. Top, for example, is the exact same thing as 1. Bottom is the exact same thing as -1. So in this example, we're going to work on the top alternate-CLI header, which is likely also the only alternate-CLI header. And we're going to try to match on that header. The expression we're matching is dot star. So recall, dot matches any character, star matches 0 or more. So you're going to see dot star a lot. Dot star matches literally anything, 0 or more of anything. So another thing to know about the star is that it's greedy, which means it tries to match as much as it possibly can. So early on, we did an example that was something like A dot star F. That's going to match A, any set of characters, and F. That dot star in the middle is also going to match any number of Fs because it's greedy. It's going to try and match as much as possible while still matching what's after the dot star. So that's why dot star is a handy shorthand here for match the entire thing. If you have just dot star, you're going to match the entire header. You put parentheses around it. That's the part in parentheses will be what gets stuffed into the variable. So you could specify a larger match expression, but you only want part of it in the variable. Just whatever's inside the parentheses is what goes into the variable. In this example, we're taking the entire alternate-CLI header, sticking it in the variable. The first action we want to take is, having saved what's in the alternate-CLI header, we want to delete that header. So that's a delete operation. You specify the source type header, source alternate-CLI. In this case, the instance is any, which means any matching header is going to be deleted. The match expression is dot star, which will match anything. So this action will delete one or more alternate CLI headers. Doesn't matter what's in the alternate CLI headers, they'll be deleted. Next, we're going to modify the p-asserted identity header. There's a fairly complicated looking regular expression there. We'll look at it in more detail on the next slide. So the match expression is double quote, dot star, double quote. That's going to match a display name, followed by angle bracket, SIP-S question, colon, all of that in parentheses, dot star at. So let's break that down into pieces. Double quote, dot star, double quote is going to match 0 or more characters inside quotation marks. And again, since the star is greedy, it would even match double quotes, but you should not have a PAI header that has more than the 2 double quotes in it. So the dot star is going to match whatever display name is already in there. Then we get to bracket SIP-S question. We already talked about SIP-S question. That's going to match either SIP or SIP-S. And then a colon. That's all in parentheses. So that's going to be captured into a numbered variable. We already looked at named variables. Those are the ones you set up front. And then as you're operating on headers, you can use numbered variables by using parentheses in your regular expression. We're capturing this so that we can reinsert the SIP or SIP-S correctly. It's followed by a dot star, which will match anything, and then an at. Again, be careful with the star because it is greedy. If there were multiple ats, you would match all the way to the last at. But in a PAI header, there should really only be one at. So that's our match expression. And the replace expression Let's see, the part in parentheses is captured into a numbered variable. That's going to be specified as $, curly bracket 1, curly bracket. If you have more than one numbered variable, the next one would be $2, then $3, and so on. So the replace expression, let's take a look at that. It's $alternate-CLI in curly brackets inside the double quotes. So we're going to take the content of that alternate-CLI variable and stick it inside double quotes. Then we're going to follow that with $, curly brackets 1. So that's either SIP colon or SIP S colon. That's the part that we captured in the match expression. Follow that by $, alternate-CLI, and then an @ So the part that matches the match expression gets replaced by the replace expression. The rest of the header is left alone. If there's more after the @ and there should be more after the @ that part is untouched. The part that matches the match expression is the only part we're going to touch. So the result then, we start with the alternate CLI header that has wealth management in it. We start with the PAI header that has 56666 in it. The alternate CLI variable is going to be set to the string wealth management. $1 is going to be set to bracket SIP colon. And the result is going to be that we're going to delete the alternate CLI header, and we're going to change the p-asserted identity header to wealth management in double quotes. And then the URI is SIP colon wealthmanagement@avaya.com with the space between wealth and management escaped into a %20. That happens automatically for you. Session Manager knows that you can't have a space in your URI, so we're just going to escape that for you, turn it into a %20. Okay, that is the second example. Any questions on the alternate CLI example? Looks like there aren't. So let's continue on to stir-shaken compliance. So the problem here, stir-shaken regulations, which took effect last summer, require that service providers reject invite requests with caller ID that doesn't match the range of numbers that are assigned to that enterprise. So the intent here is that you can't set up your own little PBX and start firing calls at people, making up your caller ID so that maybe they answer your call and listen to your pitch about extended car warranties or whatever. You're not allowed to make up caller ID anymore. You've got to use the caller ID that is assigned to you by the service provider. And if you use a caller ID that the service provider doesn't recognize as belonging to you, they can reject the call. So the problem here is if you receive a call from the public network to one of your CM endpoints, and that endpoint is forwarding it out to the public network to a service provider via Session Manager, then out to a SIP service provider, the outgoing invite is going to contain the original caller's number. And the service provider is going to look at that and say, that's not one of your assigned numbers, I'm going to reject this invite. If you want to work around that, you can use a regular expression adaptation to change the caller ID in the invite to the caller ID associated with the forwarding endpoint. So that's the CM endpoint that's forwarded back out to the network. Let's take a look at how we do that. First, let's take a look at the invite that's coming from CM to SM. If you look at the from header, this would be the external number that placed the call to your CM endpoint. That same external digit string is in the contact header. It's also in the p-asserted identity header. But that's not the caller ID of the forwarding station. It's a caller ID that doesn't belong to your enterprise, so the service provider is going to reject it. If you look in the history info, you'll see there's a redirection reason there, cause %3D CFI. The %3D is the escaped version of an equals. So the cause equals CFI, that's call forwarding immediate. And the digit string there in the history info, that would be the forwarding number. That's the number of the endpoint that's got call forwarding active. That's what you want to put in the caller ID so that the service provider does not reject your invite. So the desired invite is going to have the number ending in 2222 in the from, the contact, and the PAI. How are we going to make this happen? First, we need a condition. We don't want to unconditionally change the from, the contact, and the PII header on any invite coming from CM. We want to do it under very special conditions. So we're setting up a CM redirect condition here. If the history info and any instance of the history info matches cause %3D, and then what we have in the parentheses here, we've got 3 strings separated by pipe characters. What that means in regular expressions is one of those 3 things. So either CFI or CFB or CFNR. So what those mean, those are the condition, the forwarding causes that CM populates, either call forwarding immediate, call forwarding busy, or call forwarding no reply. So if you see one of those 3 causes, you're going to want to do this modification. So this is what your adaptation rule is going to look like. The rule has a condition, so that condition we just built for CM redirect, we apply that to this rule. It's an incoming rule, so we're applying it to something coming in from CM to Session Manager. I didn't mention this earlier. These adaptations will get applied to particular SIP entities. So this particular adaptation you're going to apply to your CM SIP entity. So anything coming from CM to the Session Manager, you're going to want to modify like this. So these adaptations, they don't apply globally. They only apply to whatever SIP entities you administer them to apply to. So first, we have a rule variable. I'm going to call this variable redirector. That's where we're going to read in the digit string corresponding to the endpoint that's forwarded. And then we're going to have 3 actions. They're identical actions just on 3 different headers, from, contact, and PAI. First thing we're going to do is try to match a history info header with a redirection cause. The source type is header, the source is history info, and the instance is going to be first match. So I want to find the first history info that matches the match expression and use that one to populate my variable. I could use something other than first match. There are other instances I could specify. In this case, I just want to use the first one that matches. The variable redirector is going to be set to whatever is inside the first pair of parentheses in the match expression. My match expression is SIP-S question mark, so that's going to match either SIP or SIP-S, colon, then we've got dot star in parentheses. That's going to be the digit string that I want to put in the variable, followed by @ then dot star, so any string of characters, until I hit cause, %3D, and then one of CFI, CFB, or CFNR. If I match all of this, then I'm going to populate the variable redirector with the digit string. The 3 actions are going to modify the from, contact, or PAI header. The instance here is any. You're only going to have one from header, but I just use the instance any to modify one or more from headers. Likewise, only one contact header, only one PAI header. I could have used one for the instance instead of any. We're going to modify those 3 in exactly the same way. We're going to replace SIP-S question mark colon dot star @ so we're going to take the beginning of the URI and we're going to replace it with $1. So that's what's inside the parentheses here, the SIP-S question mark part, colon $redirector, that's the contents of the redirector variable, and @ so we replace the match expression with the replace expression. So now we've changed the from, contact, and PAI to point at the redirecting station rather than the original caller. So that is that's the stir shaken example. I'll take a look for questions. Wow, one just showed up. So we got a couple of questions here. Can you get the presentation so you can reference it afterwards? I'm pretty sure the users group is going to make that available to you. So yeah, I think the answer is definitely yes. So a question about stir shaken. How can you address those numbers that come into CM that are not known or just callers not accounted for in SM and get passed through CM and out to the service provider, like in an EC500 scenario. Those would probably be dropped too, that's true. In your example, it looks like you know the incoming caller number ahead of time to configure an adaptation. No, that's not true, actually. This modifies any incoming number. If you had an unknown number, if it showed up as anonymous, for example, I'm not 100% certain my example would handle that for you. We'd have to look at the incoming SIP messages and see what exactly we're trying to match. But my adaptation, if we back up, I mean, I give you an example with a specific caller number. My example here, it's the number ending in 1111, but the adaptation that we set up does not depend on that at all. It doesn't match the caller number at all. It just replaces whatever was in the caller. So if you look at my rules, we're just going to replace whatever is in the from, contact, and PAI. It doesn't matter what it was before, it's going to get replaced. That's what that dot star before the add is about. I don't care what's there. And so, as I look at this, if it were anonymous rather than a digit string, this would still match. So you'd be fine. I hope that answers that question. Okay, on to our next example, making undialable call log digit strings dialable. The problem, this is a pretty elaborate problem. If you use centralized call history on Session Manager, you may have run into this problem before. So you place an outgoing call from your SIP endpoint, for example, an Avaya hard phone. This also works on the Avaya Workplace app, for example. You place an outgoing call, and the digits you dialed wind up in your endpoint's outgoing call history. Now, if you happen to have the sort of enterprise where everybody logs out of their endpoint when they go home at night, you'll notice that when you log back in the next day, the endpoint's call history is not what was locally maintained on the endpoint, but rather it's what the endpoint received from Session Manager. The way this works is while you're logged into your endpoint, the endpoint keeps local call history. So it logs whatever digits you dialed, whether it's an ARS access code followed by a bunch of digits that are sent to the service provider, or whether it's an extension, just exactly whatever digits you dial get logged by the endpoint. Also, Session Manager is logging your calls so that when you log out and log back in, you can reload your call history. And the reason for this feature is that maybe you've got multiple people sharing the same endpoint. One person logs out, the next person logs into that endpoint. They want their own call history. They don't want the previous person's call history, they want their own call history. So Session Manager keeps track of each user's call history, and when a user logs into an endpoint, that call history that Session Manager maintains gets loaded into the endpoint. The problem here is that the digit strings are stored differently by the endpoint and by Session Manager. The endpoint logs exactly what you dialed. Session Manager, on the other hand, will log the digit string after manipulation by CM. So the idea there was to give you something that's more representative of the actual dialed number rather than the digits you dialed. And there was a lengthy debate as we built this feature over what exactly should be stored in the Session Manager call history. This was the design decision, and unfortunately, one side effect is when you log out and log back into your endpoint, your call history now, imagine you dialed 9, the ARS access code, followed by 10 digits. That got you out to the service provider to whatever number you're calling. But what's actually stored in the Session Manager call history could very well be an E164 number. So +1 followed by 10 digits. And when you click on that entry in your call history, it's not dialable. That's not part of your dial plan. You need to insert the ARS access code. You don't want the plus in there. Just the digit string that was stored there is not dialable. So how do we fix this? We've got customers for whom this is a big deal, and they want a fix for it. And one fix, of course, would be to change the call history feature. Maybe add some more flexibility as to what exactly is stored. Do you want to store exactly what you dialed, or do you want to store the digits after they've been massaged? That's one option, but if you wanted that solution, you'd have to wait for a new release of Session Manager. Here, we're going to use Adaptation to fix this problem without any sort of new release of Session Manager. So the solution, we're going to use a regular expression adaptation and a device mapping. We're going to insert the ARS access code in front of the digits the endpoint dialed. Now, this works best with a simple dial plan. For example, we're going to send all 10-digit numbers to ARS. There are other ways you can do this. You could use egress digit adaptation before you go to CM. I think that makes the solution a little more complicated. And the particular customer that brought this up to us is in Germany. And the dial plan in Germany is a good deal more complicated than in North America. You can't just say something like, well, all 10-digit numbers must go to ARS. It's a good deal more complicated. I'm going to show you the simple version of the solution that you could apply in North America. A quick word about device mappings. We used to have something called endpoint adaptations. They were hidden. There was no administration you could do. You couldn't enable them or disable them. They were just always there. These were used to do adaptations for particular vendors, like if you had Cisco endpoints or maybe a Cisco PBX. There were certain things that needed to be massaged in order to make those invites palatable to CM. Recently, we exposed all those hidden endpoint adaptations so that we could allow customers to add their own endpoint adaptations without waiting for Avaya to develop those, or so they could maybe modify the existing ones. Like if the Cisco adaptation doesn't do exactly what you want, you can go modify it and make it do precisely what you want. What we're going to do here is we're going to add an additional device mapping to change the request URI. So each device mapping will map either a user agent header, which is really just the endpoint type. It's how the endpoint identifies itself, or an origination dial pattern set to an adaptation. An origination dial pattern set is really just a collection of users that you want this to apply to. Here's what the device mappings look like on System Manager. You start with the 4 Avaya provided device mappings, and then you can just add on from there. We're going to add one device mapping called call log dialing. We're not going to specify a user agent because we're not basing this on the type of endpoint you're using. Instead, we're going to have an origination dial pattern set. I'm calling it call log adaptation, and that will specify the set of users that will take advantage of this new feature we're building here. The details of the device mapping, again, we've got the origination dial pattern set, call log adaptation there. The adaptation we're using is also called call log adaptation. It's a regular expression adaptation, and we'll see that adaptation in a second. One thing to keep in mind with the device mappings is that they are applied in order until one of these device mappings applies. So if you're calling from a Cisco endpoint, you're going to match that user agent Cisco. That's that first device mapping we have on the list. You're not going to make it all the way down to the call log dialing device mapping, so that won't be applied. If you want this to apply to all endpoint types, then you would need to put that at the top of the list in front of the Avaya provided device mappings. So let's move on to the adaptation. Oh, nope, first we're going to talk about the origination dial pattern set. So here's where we specify which users we want this to apply to. You could have it apply to all users by just using a wildcard pattern, X with minimum 1, maximum 32 or something like that. In my example here, we're applying this to the pattern 5-2 with min 5, max 5. So any 5-digit number that starts with 5-2, and also 53001 with min 5, max 5. So the user 53001. So this is the set of users that this adaptation is going to apply to. Here's where we're going to insert the ARS access code. It's an incoming adaptation, so incoming to Session Manager from the endpoint. We don't have a condition in this particular case. We could add a condition if you wanted to make this even more specific. So we're going to modify the request line, the request URI specifically in the request line. If we match, well, let's go to the next page where we have more detail on this. Let's see, do we have new questions? There's a lengthy stir-shaken question here. Let me take a quick look at this and see whether I can answer it quickly or whether I have to defer it. Yeah, that's really a more complicated question than I'm going to have time to answer here. You know, in the past, the users group has provided me with a list of the questions that were submitted, and I've answered those in writing after the presentation. So if we can do that again today, I'll see if I can get you an answer to the particular stir-shaking question here. Another question, this presentation was given at Engage. Well, it wasn't given by me, and I'm not sure who else would have given it, so the answer to that one is no. Are the only Avaya device mappings scan terminating? Looks like you scan down through the user-entered adaptations, but then until you match the first Avaya match. There's no distinction between the Avaya adaptations and the user-entered adaptations. It's just one long list of device mappings. You can, if you want, delete the Avaya device mappings. If you don't use Cisco endpoints, then go ahead and delete that one. You can put your own device mappings higher up in the list than the Avaya mappings. That's fine too. The way it works is we go down the list until we get a match. We either match the user agent header or the origination dial pattern set. Once we match one, that's the adaptation that gets used, and the rest of them aren't even looked at. I think that answers the question. Can we remove a specific header parameter? Absolutely. You can remove anything you want. It's just a question of coming up with the right regular expression to do it. Okay, so those are the questions for now. So let's look in detail on how we're inserting the ARS access code. And this is admittedly sort of a contrived example. I'm assuming in this example, you only want to insert the access code in front of a 10-digit number starting with 720. You need to tailor this to your own dial plan. For example, you could say any 10-digit number you're going to put ARS access code in front of. Or, you know, if you're in a different part of the world, it gets more complicated than that. My match expression, SIP-S question mark, we've seen that before. We're going to capture that. We're going to reinsert it when we do the replace expression, colon, and then in parentheses, we've got 720. We haven't seen the square brackets before. The square brackets mean one character from this set of characters. So in this case, we've got 0 through 9. So one of 0 through 9. And then we've got the curly brackets after that. That's a quantifier. So that means I want 7 of the thing that was before this. So the 7 in curly brackets means 7 of 0 through 9. So basically just 7-digit characters. So we've got a 720 followed by any 7 digits. The SIP-S question mark part is going to capture either SIP or SIP-S into $1. And then the second parenthesized expression is going to capture 720 followed by 7 or more digits, exactly 7 more digits into the variable $2. The replace expression is $1 colon *99 $2. In my example here, *99 is the ARS access code. So we're just going to slip that *99 between the contents of variable 1 and variable 2. So now when your endpoint dials a 10-digit number starting with 720, SM is going to insert the *9 before sending the call to CM. And then CM will see the ARS access code and route appropriately. Let's see, so that's the end of that example. One more example remaining. Let's take a quick look at the questions. To turn on device mappings, is there any restriction, or do you just go to global settings and enable? Nope, just a global setting to turn it on. Is there a good list of user agent headers of Avaya devices? I don't know that we've published a list, and you know, the instant we publish a list, it'll be out of date. as we come out with new endpoints. I find the easiest way is to just collect the SIP trace using a tool like TraceSM, for example, or maybe even Wireshark, and then just see what your endpoints are sticking in the user agent header. For Avaya devices in particular, I think you're pretty safe just using the string Avaya. Avaya is going to be in there somewhere. If you want to restrict it to specific types of Avaya endpoints, then yeah, you need to look at an example invite from that endpoint and see what it's putting in the user agent header. Unfortunately, it's not very standardized. We've got a wide range of Avaya endpoints, and they all do things just a little differently. In the scenario of having an ASBCE between SM and the service provider, does it matter where the adaptation is done? No, not really. If you prefer to do it on the SBC, feel free. This just gives you another option. If you're going out the SBC before you need the digit string changed, then feel free to do this in the SBC. Like I said before, there are two reasons why you might do this on the SM. One is if you're trying to do the adaptation inside your enterprise without having an SBC in between. And the other reason is, personally, I think the session manager adaptation is a little easier to use than the SBC scripting language. Another question, we get spam calls from a CNAME or display name of V225, then a variable set of digits up to 18 digits long. How can I block these callers? That's actually a nice application for regular expression adaptation, and we can probably come up with a way to do this. Unfortunately, it's a little longer than we have time for. So again, when I do the written answers, I'll write up an example of how you could do something like that. Can SM adaptation to block inbound known spam caller instead of SBC? So can we use SM adaptation to block inbound known spam callers instead of the SBC? Absolutely. You can do it either place. If you prefer to do it on SM, you can absolutely do it. And again, when I provide written answers, I'll give you a little more detail on the sorts of things you would want to do there. Okay, the final example, call by call, caller ID blocking. Again, a real customer problem. Users want to be able to block their caller ID when they're making certain internal calls. I don't know what the specific customer scenario is, but imagine that you've got a doctor in a hospital calling a patient room and not wanting to expose their direct number to the patient. So that doctor wants to not generally block their caller ID, but they want to block the caller ID when they're calling a patient room. There is no SM or CM support for such a feature. What you can do on CM is you can block caller ID call by call for external calls, but you can only block caller ID for all internal calls. You would do that based on class of restriction. So you could have a particular endpoint in a class of restriction where their caller ID is always blocked, but that's not what you want in this scenario. You want to have, imagine a feature access code that on this particular call, I want to block my caller ID, but in general, I want my caller ID displayed. So the solution here, we'll create a condition that looks for a request URI starting with a feature access code, and I put feature access code in quotes because this is going to be a made-up feature access code. It's not an actual CM feature access code. We're going to create an adaptation that anonymizes the call if the condition is met. We're going to add that adaptation to a device mapping. You could optionally associate the device mapping with an origination dial pattern set that restricts this new feature to a specific set of users, or you could just leave it available to everybody. You know, it's your choice. As I was cobbling this example together in lab, and by the way, all these examples I actually set up in the lab and verified that they actually do what I claim they do. As I was setting this particular one up, I hit a roadblock very early, and that is the endpoint dial plan. So when a SIP endpoint registers with Session Manager, PPM will communicate the dial plan, among many other things like call history, for example, to the endpoint, and PPM gets this dial plan from CM, indirectly from CM. That includes AAR and ARS. And if you dial something on your endpoint that doesn't match the dial plan, then you'll get intercept tone. And that comes from the endpoint itself, not from session manager or CM or whatever, because the endpoint knows the dial plan. So if I want to make up this new feature access code, it needs to be in the endpoint dial plan. It needs to be in the dial plan that the endpoint has gotten from CM. So that was the first thing that happened. I said, okay, let's make up a feature access code. Let's call it 6.7. I dial 6.7 and the endpoint says, nah, you can't dial 6.7. So I need to add the 6.7 plus my 5-digit extension to the CM dial plan. Not a big deal, just you need to know that you have to do this. So the dialed string is 6.7, total length is going to be 7, so it's 6.7 plus whatever 5 digits. And I administer that as an extension on the CM. I don't actually have extensions that match this. I just need the endpoint to get this dial plan and say, 6.7 is a valid digit string that I can dial. Okay, so once we get past that, the naive approach is let's create an endpoint adaptation that's going to anonymize the from, contact, and PAI headers. Well, that doesn't actually work because the PAI header gets inserted by SM. So if you're trying to remove the PAI header before SM inserts it, that's going to be pointless. SM is just going to go ahead and insert the PAI. Then you've got the PAI in the invite that the called endpoint sees. It has the caller identification. You haven't achieved the effect you're trying to achieve here. A better approach is to create an endpoint adaptation that's going to insert a privacy header. This is a header that's specified by RFC 3325. If the invite has a privacy header with privacy type ID, then Session Manager is going to strip out the PAI before sending the invite to the endpoint. So the endpoint is not going to display the caller ID. There won't be a caller ID for the endpoint to display. Also, when CM sees this privacy header, it's going to anonymize the from and contact headers. So let's take a look at what that looks like. First, the condition we're going to use. This condition checks that the endpoint is dialing something starting with 6.7. Very simple condition. We're going to match SIP-S question mark, so either SIP or SIP-S, colon 6.7. That's all we're matching in the request URI. If we see that in the request URI, then this anonymizing feature is going to apply. So here's the adaptation to insert the privacy header. The condition is the anonymizer condition we just saw in the last slide. It's an incoming adaptation, so this applies coming from the endpoint to the session manager. And there are two things we're going to do here. First, we need to modify the request URI to take out the 6.7. Second, we're going to insert the privacy header. And let's take a little more detailed look at what we have here. So the match expression against the request URI is going to be SIP-S question mark colon, all of that in parentheses. So that gets stuck into the variable $1. We're also going to match the 6.7. So only if we see that 6.7 are we going to do this replacement. We're going to replace it with $1. So that'll just reinsert the SIP colon or the SIP-S colon, but not the 6.7. The second part of the adaptation, the second action is just going to add a privacy header with value ID. That's all there is to this. Let's see, we have a couple more questions here. So a follow-up to the header parameter question, can we modify an ACK? It's a very elaborate question here. I will be answering this in writing since we're getting short on time here. Is it possible to limit device adaptations to certain IP ranges? No, we don't have a way to do this based on IP ranges. We only do it based on user agent or user. So if you can come up with an origination dial pattern set that encompasses the users you're interested in, you can certainly do this, but we can't do it based on IP ranges. That's an interesting idea. We hadn't thought of that. Okay, continuing with this device mapping. So we add this adaptation to a device mapping called anonymizer. We're going to specify an anonymizer origination dial pattern set to limit this feature to just a certain collection of users. Just one adaptation, that's the anonymizer adaptation. So how does this wind up working? There's an invite from the caller to the session manager. The request URI is SIP colon 6752003. So 6.7, that would be my fake feature access code. The contact has, the contact and the from header both have the caller ID of the caller. That's what we're going to want to anonymize. So we insert the privacy header in this adaptation. This is the invite that goes from Session Manager to CM. So Session Manager has done this adaptation. Here's what winds up going to the CM. The 6.7 has been stripped out. That's the red highlighted part. The yellow highlighted parts, the contact and the from, those have not been changed yet. Since our adaptation doesn't mess with the contact or the from. Session Manager has inserted the PAI. That has nothing to do with this adaptation. That's just something that Session Manager does when it recognizes that an invite is coming from a registered and authenticated endpoint. You'll see in blue the privacy header. That's what this adaptation did. It inserted the privacy header. So now let's continue on. When the invite comes back from CM to Session Manager, CM has seen the privacy header and it has anonymized the from and the contact. The contact no longer has the user part in it. It's SIP:IP address, and it's not the IP address of the endpoint, it's the IP address of the CM. So there's no trace of which endpoint is making this call in the contact header. And in the from header, we now have the display name anonymous and the URI SIP:/anonymous@anonymous.invalid. So no sign of the real caller ID in the from header anymore. So CM did that in response to the privacy header. The PAI header has not been touched yet. So now SM gets another whack at this request. SM sees the privacy header before it proxies the invite out to the callee endpoint. It's not going to touch the contact or the from. Those are already anonymized by CM. But because there's a privacy header, it's going to strip out the PAI header. So now this invite on the bottom going from SM to the callee has no caller ID in it anymore. Because this is now enabled through a fake feature access code, you can do this call by call. Okay, I believe that's the end of this example. Yes, it is. So we've got a little more time for questions. Let's see, we have a few more questions. If the condition is SIP-S question:67, are the digits always read from left to right? Yes, it's always going to be the first two digits. If you wanted to, I mean, you could concoct an example where in order to anonymize your call, you dial the callee's extension followed by 6.7. Regular expressions will let you do that. It's not the most convenient way to implement this, but you could certainly do it. You would just have to specify, 5 digits followed by 6.7. Okay, I want to keep the 5 digits, get rid of the 6.7. But for simplicity's sake, I think you're going to want to do it this way, where you delete the first 2 digits and then keep the remaining digits. Recall that in regular expression adaptation, you're going to replace whatever matches. So anything that was outside the match expression is unchanged. In this example, anything following the 6.7 will be unchanged. So why couldn't we use the regular expression to the right of the @ to do it by IP? So if this relates back to limiting the device adaptation to certain IP ranges, yeah, you could certainly do that, but it'll be more elaborate. You wouldn't really be using the device mapping in that case, because the only conditions on the device mapping are user agent or origination dial pattern set. But you could set up your adaptation such that the adaptation will only match on certain IP addresses. You can certainly do that. We didn't talk much about IP address matching in this presentation. In previous presentations I have, and the caveat I would give you is that if you're trying to match a particular range of IP addresses, the regular expressions can get pretty gnarly, and it gets even worse if you're using IPv6. So trying to match IP addresses with regular expressions is a little bit of an art form. If you search for that sort of thing on the internet, you'll find articles describing it. Let's see, other questions. Will you have access to the demo? If you mean the slide deck, I'm pretty sure you will have access via the users group. Has REG-EX changed from SM8 to SM10? Back in 8.01, we added regular expression adaptation. Since then, we've added device mapping. It doesn't really change regular expression adaptation any. It's just that you can now apply the regular expression adaptations to endpoints via device mappings. So no, I wouldn't say REG-EX has changed significantly from SM8 to SM10. And then there's a follow-up question about IP addresses. So it makes the very valid point that one of the tricks with IP addresses is that you have to backslash the dots in the IP address, otherwise you get unexpected behavior. Recall that dot is a wildcard character. So if I do, for example, 1.2, it will match 1.2. It'll also match 122 or 132 or whatever. So you need to put a backslash in front of that dot, or you might match something you didn't intend to match. Are there other categories listed online that I've presented related to call routing? You know, that's an interesting question. I was surprised. I personally don't put these things online. The user group does. These are user group sponsored webinars. And I was surprised a couple weeks ago when I was Googling for something about device mappings. I was looking for the Avaya documentation on device mappings, and I noticed that one of the first hits that came up on Google was actually a YouTube video of a presentation I gave for the users group. So there are videos on YouTube of these talks I've given. I haven't put them there, the users group has, which is perfectly fine. But you should be able to find previous talks. I've done 4 of these now. Before testing regexes, should we be using Java or Perl in tester applications? Boy, that is a really good question. Let me show you my my system manager, because there's a feature I want to point out to you. Give me a second to log in my system manager and I'll show you what I've got here. I'm not sharing the system manager just yet because I don't want you to see my terrible, terrible security practice where I put the password for my system manager right on the splash screen. It's very embarrassing. Okay, so here's my system manager any second now. This is why I tend not to do live demos, because you never know whether things are going to work. All right, let's go to a regular expression adaptation. There is a regular expression tester built in here. So if we go to my 606, is this a good example? It might be a good example, I don't know. Yeah, so here we are on the rule actions, and this icon right here takes you to the regular expression tester. So my regular expression 606, I mean, this is not a very interesting regular expression. I want to test against it. Let's test 503 against it. Test, no match. Okay, 606, whoops. Test, successful match. Now, if we used a more interesting regular expression like digits 0 through 9, and I want exactly 3 of them, so I'm going to start with 1, 2, 3, 4. No, this actually will match because I have more than 3. And it shows you which part of the string matched. So the 1, 2, 3 part matched my 3-digit expression. If I only had 2 digits here, this would not match. Okay, no match. And this works with fairly complicated regular expressions. So just click on this item to fiddle around with your regular expressions and test them. You don't have to go find a regular expression tester. I guess another aspect of this particular question is, should you be using a Java or a Perl regular expression tester? If you're going to use a regular expression tester other than the one I'm showing you here, you should be using a Java regular expression tester because this is all built on Java rather than Perl. And there will be some very subtle differences between Java and Perl. Differences that you likely won't notice in general, but you may stumble over one of those differences if you're dealing with more complicated regular expressions. Okay, we seem to have come to the end of the questions. So thank you for your attention. Thank you for your questions. And thank you to the users group for giving me this platform to help you use regular expression adaptation more effectively. Like I said, I've done 4 of these now, and unfortunately, this is going to be the very last one of these that I do because I am about a week away from retirement. So this is my last week with Avaya. Okay, well, thank you for listening.
Thank you, Dennis. Thanks for taking the time to speak to us today and for squeezing in a last IAUG webcast before you head off to retirement. We really appreciate it.